Today we're going to talk about long division and synthetic division, which is something that we did last year, so this is just review. So we can use the properties of exponents to divide a monomial by another monomial term, which means, remember, monomial is one term, and a polynomial by one term, or a monomial. So for this, if we look at question number 1, since there's no addition or subtraction between any of the terms, we can just use our properties of exponents to simplify. So 48 divided by 6 gives us 8. And then remember, when we're dividing something to the same base, we subtract the exponent. So this would be 2 minus 5 and b to the 7 minus 3. And then we just have to simplify. So this is 8a to the negative 3, b to the 4th power. And remember, when we have a negative exponent, that goes to the denominator if it's in the numerator, and if it's in the denominator, it goes to the numerator, so it just depends on where you are. So since we're up here, we're going to bring that down to the denominator. So this becomes 8b to the 4th over a cubed. So over here, same idea, except for we have more than one term in the numerator separated by addition and subtraction signs. So the best way to think about this one is just splitting each of these up by dividing it by 3rs. So we have 6r squared s squared divided by 3rs plus 3rs squared over 3rs minus 9r squared s over 3rs. And then we're just going to simplify. So 6 divided by 3, of course, is 2. R squared over r becomes r, and s squared over s becomes s, plus the 3 over 3 is just 1, so you can write the 1 placeholder if you want, but you don't have to. R over r is just 1, and then s squared over s is s, so 1s, or again just s, minus 9 divided by 3 is 3, and then we would end up with r. And again, you don't need that 1 there, you can leave it off. So that would be our simplification. So that only works when you're dividing by one term. So remember, terms are separated by addition and subtraction. So polynomial long division. The dividend, remember, when we're doing polynomial long division, must be in standard form, and if needed, you have to add in your 0 placeholders. So recall that the dividend equals the divisor times the quotient plus the remainder. If the division has a remainder of 0, then we say the divisor and the quotient are said not to be factors of the dividend. If the division does not have a remainder of 0, then the divisor and the quotient are not factors. So just as a recall right here, if we're dividing f of x by d of x, so f of x is your dividend, d of x is your divisor, q of x is your quotient, and r of x is your remainder. So over here, when we did our polynomial long division, so remember we said that this right here is your dividend. So notice that we're dividing a polynomial by a binomial, which means 2 terms. So if we're dividing it more than one term, we can't use what we did above. We have to do our long division. So remember that the divisor goes on the outside, and the dividend is going to go underneath our sign for division. And so remember, if you're missing any 0 placeholders, you need to add those in. So this is a degree 2. Degree 1, and this is degree 0 if it's not written, so we're not missing any 0 placeholders. So 6x squared minus 17x plus 32. And if you recall from last year, I used does, McDonald, sell, burgers, repeat. So the D stands for divide. So D stands for divide. So I like to do my work off to the side here. So what do we divide? We divide our first terms, because remember, you can rewrite this as 6x squared minus 17x plus 32 divided by x plus 2. So when you're dividing, you're still thinking about dividing these first terms right here. So we're going to divide those first terms, the 6x squared and the x. And then we're going to reduce using our properties of exponents now. So this just becomes 6x, and notice then that is linear. So we line up our terms. Your linear terms get lined up with the linear terms. So that goes right here because that's above the 17x, which is linear. And then M stands for multiply. So the next step is to multiply the 6x times x and 6x times 2. So 6x times x is 6x squared. 6x times 2 gives us 12x. And then remember, when you're doing long division, you are subtracting. So we're going to subtract our terms. So a couple different ways. I like to just leave the signs here and then I circle the ones that I have changed, or you could put it on the outside. I'll do both ways. I'll do the way that I like to do it, and then I'll do the other way in the next problem. So this was originally a positive 6x squared, so to subtract that becomes a minus, and this 12 becomes also a minus. And again, I circled the signs so I remember that I've already changed them. And we did this on purpose. So notice that your first term should cancel out. So 6x squared minus 6x squared ends up canceling out. If it doesn't, then we know we did something wrong. Then we have 17, negative 17, x minus 12, which gives us minus 29x. And then B stands for bring down. So we bring down that last term that didn't have anything to go with it, so the 32. And then R stands for repeat. So we're going to repeat these steps again. So I'm going to erase this over here. So again, the first steps are to first divide. So we're going to divide those first terms. So now my first term is the negative 29 and the x. So negative 29x divided by x gives me negative 29. That's a constant term, so I'm going to put that above my constant terms. M stands for multiply, so negative 29 times both these terms here, and then we're going to line them up. So negative 29 times x is negative 29x. Negative 29 times 2 gives me negative 58. And then again, we are going to subtract. So this minus becomes a plus, and this becomes a plus as well. And again, I'm circling so I don't forget that I changed the signs. And then notice that the first terms cancel out, which we did on purpose. If they didn't cancel out, then we know we did something wrong. So now we have 32 plus 58, which gives us 90. And notice that there's no other spots for the 90 to go into. And if we try to do 90 over x, we would have x in our denominator. So that tells us that this is the remainder then, since there's no other spots. So if I write out my quotient, which is my answer, and the remainder, we have 6x minus 29 plus the remainder, which is 90 divided by x plus 2, because the x plus 2 couldn't go in anymore. And that gives us our equation. So let's go ahead and look at the next one. We're going to do the same thing. We're just going to practice our long division. So first things first, we want to start setting up our equation. So if you look here though, looking at our dividend, we are missing some zero placeholder. This is a degree 4. We're missing a degree 3 because this is degree 2, and we're missing degree 1, and this is degree 0. So that means we need to add in our zero placeholders for x cubed and x to the first power. So on the outside first goes my divisor, which is the x plus 2. And then underneath is our dividend. So we have x to the 4th plus 0x cubed minus 2x squared plus 0x minus 20. So again, always add in those zero placeholders. So the x cubed and the 0x are the zero placeholders that we wanted to add in. So now I'm going to do my work off to the side. So does McDonald's sell burgers? Repeat. First one's to divide. So we divide those first terms. So the x to the 4th over the x, which gives us x cubed. So since we get x cubed, that is a cubic term. So that's going to get lined up with our cubic terms. Then m stands for multiply. So we take the x cubed times x, which is x to the 4th. And we did that on purpose because those are going to end up canceling out. And x cubed times 2 would give us 2x cubed, which is why we need the placeholder so that we have the spots to add that when we are doing our long division. So now that I have this, the other way that I was talking about, instead of changing the signs as you go, which is usually, like I said, what I like to do, you could also just do a parentheses and put the negative on the outside, and then you have to remember to distribute the negative as you're subtracting. So you would get x to the 4th over minus x to the 4th, which cancels out, and 0x cubed minus, because you're going to distribute the negative to the 2x cubed, would give us instead, negative 2x cubed, and then the rest of them we're going to bring down. So we have minus 2x squared plus 0x minus 20, and then we repeat. So we have our first term now is negative 2x cubed divided by x. So when I divide those, I get negative 2x squared. That is a quadratic term, so I'm going to put it above the quadratic term. So minus 2x squared, and then we multiply. Negative 2x squared times x gives me negative 2x cubed. Negative 2x squared times 2 gives me minus 4x squared. And then we're going to subtract. And again, if you like to do the negative on the outside, and just remember to distribute the negative when you're subtracting, that's fine. Or I'm going to do the way that I like to do it, with just changing the sign so I don't forget. So this one becomes a plus, and this becomes a plus. And so then those first terms would cancel out, which we did on purpose. We have negative 2x squared plus 4x squared, which is 2x squared. And then we bring down our next terms, plus 0x minus 20. And then we start all over again. So our first term is now 2x squared divided by x, which gives us 2x. It's positive, so plus 2x goes above the linear terms. And then we multiply. 2x times x is 2x squared. 2x times 2 is plus 4x, or 4x. And then the next step is to subtract. So again, you can write the minus on the outside, or you can do what I like to do, which is just change the signs and circle them so I remember I already changed them. And then our first terms, notice it cancel out, which we did on purpose. If they do not, we did something wrong. And then we're going to take 0x minus 4x is negative 4x, bring down the minus 20, and then start all over again. We're going to repeat. So now we have minus 4x divided by x, which is negative 4. So negative 4 is our last one that we're going to do, and that's our constant. And the rest is going to be a remainder after that. So negative 4 times x is negative 4x. Negative 4 times 2 gives us minus 8. And then we're going to change those signs. So that cancels out. And then negative 20 plus 8 gives us negative 12. There's no other spots to go, so this is our remainder. And now we just have to write our equation. So we have x cubed minus 2x squared plus 2x minus 4, and then minus 12 over our divisor, x plus 2. And again, so because we didn't get 0 for a remainder for either of these two, that tells us that x plus 2 is not a factor of either of these two equations. All right, so the next thing we're going to talk about is our synthetic division. So hopefully you remember synthetic division from last year. Now, remember, synthetic division we talked about last year can only be used when the divisor is a linear binomial with a leading coefficient of 1. If that is not the case, then you have to use long division. So just keep that in mind. So if I look over here, looking at the divisor here is x plus 3. And so since the divisor is x plus 3, that's linear because it has the highest power of x. It's a binomial because there's two terms, and the leading coefficient in front of our highest power of x is only 1, so we can do synthetic division. So remember, when you're doing synthetic division, the first thing we do is take that divisor, set it equal to 0, and find the 0. So x equals negative 3. That is the number that goes inside the box. So for our synthetic division, then you'll notice that if we were missing any 0 placeholders, just like long division, we would put them in. So where did these numbers come from? This was from our x cubed plus 4x squared minus x minus 1. So notice that there's a coefficient of 1 in here. So these are the coefficients of the numbers. So we take the coefficients, and now we're going to bring down the first term, which is 1. So you bring down, then you multiply. So what do I multiply? I take what the number is 1 times the box. So 1 times negative 3 is negative 3, and that number goes here. So you multiply, then you're going to add. We always add for synthetic division. So we're going to add 4 and negative 3, which gives us 1. And then we're going to repeat. So 1 times the box gives us -3 again. Add these two together to get -4, and then repeat. -4 times -3 is 12. Add those together to get the last number, which is the remainder, which is 11. Now, remember when you're dividing these, your answer is always going to be 1 less degree than your dividend. And that's because you're taking x cubed plus 4x squared minus x minus 1, and you're dividing it by x plus 3. So if you think about dividing these first terms, that means that when you divide them, you're going to start off with something that's quadratic in this case because the degree difference is 1. So it's always 1 less than, again, your dividend. So this would be x squared plus x minus 4, and the remainder is positive, so plus 11 over our divisor x plus 3. And that was for our synthetic division. So hopefully this is bringing back some good memories of last year. All right, so next part says we're going to factor a polynomial given a factor. So if you are factoring a polynomial given a factor, remember that means the remainder should always equal 0. If it does not, then something went wrong. So for this, we can do long division or synthetic division. Either will work because this is dividing by the factor is a linear binomial with a leading coefficient of 1. So let's go ahead and practice our synthetic division. So for synthetic division, we have to figure out what number goes inside the box, which is the 0 of the what you're dividing by, so the divisor. So we get x equals -2, so that's the number that goes in the box. I have degree 3, 2, 1, 0, so we're not missing any 0 placeholders for the synthetic division, so we can use our coefficients then. So we have 1, -5, -2, and 24. So we're going to go ahead and bring down our first term, which is the 1. Then we're going to multiply. So 1 times -2 gives me -2. Add them together, which gives us -7. -7 times 2 gives us +14. Add those together to get 12. 12 times -2 is -24. And then notice that our remainder is 0, which is what we want because it says it's a factor. So now we have to look at our divisor, which was degree 3. So that means our answer, which is our quotient, is going to be degree 2. So x squared minus 7x plus 12. So the question says to factor the polynomial given a factor. So we know that x plus 2 is a factor, but now we're using that to factor this polynomial. So we have x squared minus 7x plus 12. That's a trinomial. It has 3 terms. So we're going to go ahead and factor this. So we want factors of 12 that add up to -7. So that's going to be x and x here. We know that the signs have to be both negative to get a positive 12 here. So factors of 12 that add up to 7 would be -4 and 3. And so again, we're factoring the polynomial. So I can't just multiply these two out. I have to also use the given factor. So then the factorization is x plus 2, because that was the given factor, times x minus 4 times x minus 3. So now we have factored our polynomial completely because I can't factor those binomials any further, but if I could, I would. And if I were to multiply this all out and combine like terms, you would get your original polynomial equation. All right, so the next part says we're going to find all the zeros, x-intercepts, solutions, roots given a 0 of the function. So for this one, it's kind of the same idea as the last problem, where if you're given a 0, then the remainder should always equal 0. So if this is the 0, then that means, remember, the 0 is what goes in the box, but we could write this as a factor. The factor would be x plus 2, And you can check your work. So if I set this equal to 0 and solve, I would get x equals -2, right? That's the 0. So the factor is the x plus 2. So we could write it as a factor if we wanted to, but it's not necessary because the 0 is what that goes in the box. So we're saying -2 is the 0. And then let's look at our coefficients. We have 9 and then 2, 1, 0. So we're not missing any 0 placeholders. So 9, 10, -17, and -2. And then we're going to bring down our first term, which is 9. 9 times -2 is -18. Add these numbers together to get -8. -8 times -2 is +16. Add these together to get -1. -1 times -2 is +2, and that gives us our remainder of 0, which is what we want. So this was a degree 3, so that means this is going to be a degree of 2, so 9x squared minus 8x minus 1. So now with this, I have to then keep factoring because we're trying to find all the zeros. So if I don't know how to factor this, I could, because it's quadratic, use the quadratic formula. So let's go ahead and practice our factoring. I like to use the method Swedish fish don't really swim. So 9 times the 1. So x squared minus 8x minus 9. So now we need factors of -9 that add up to -8. So when we write our factors, we know that would be -9 and +1. And then we have to, if we move the 9 from the beginning, we have to divide it back out. Reduce our fractions. So 9 over 9 gives us x minus 1. And then this doesn't reduce, so the 9 swings in front. So 9x plus 1 would be our factorization. So if we were to write the factored form for this, it would be x plus 2 times x minus 1 times 9x plus 1. So that would be the last question that we just did. But this is asking us to find the zeros. So since this is asking us to find the zeros, we want to set each factor equal to 0 and solve. So x plus 2 equals 0, x minus 1 equals 0, and 9x plus 1 equals 0. So when I solve, we know the first one's -2, that was given. Then we get x equals 1, and for this one, x equals -1/9 when I subtract the 1 and divide by 9. So those are our zeros. You can write them as together if you want. So -2, 1, and -1/9. All right, so let's look at question number 8. So for question number 8, we're going to do the same thing. Find all the zeros given one of the zeros is -7. So in the box goes -7. And then I have degree 3, 2, 1, 0. I'm not missing any 0 placeholders, so I can write the coefficients of my dividend. And we're going to bring down that 3. 3 times -7 is -21. Add those together to get 0. 0 times -7 is 0. Add those together to get -15. -15 times -7 is +105. Add those together to get your remainder of 0, which we know we should happen on purpose. So this was a degree of 3, so we want our answer to be a degree of 2. So 3x squared plus 0x minus 15. So we don't really need that 0x, so we have 3x squared minus 15. And so we know that's a factor. If we have x is -7, we can write that as x plus 7 as the factor. And then we're trying to, again, find all the zeros. So we can actually factor out a 3 here too. So if I factored out the 3, this would be 3 times x squared minus 5. And then that's not the difference of two squares because this 5 would be is not a perfect square. So this factorization would be 3 times x plus 7 times x squared minus 5. But again, we're trying to find the zero. So let's set each of these equal to 0 and solve. So we don't set 3 equal to 0 because it's not. It doesn't have an x with it. So x plus 7 equals 0. So x equals -7. And x squared minus 5 equals 0. So x squared equals 5. And x equals plus or minus the square root of 5 when you take the square root of both sides. So your zeros are x equals -7, which was given, and plus or minus the square root of 5. So that makes sense too, because another thing you want to think about, which we haven't talked about yet, but if you have a polynomial degree 3 by the fundamental theorem of algebra, you should have that many zeros, whether or not they're real or imaginary. So in this case, I should have 3 zeros, and for both of these, I do. So whatever the degree of your polynomial is, that tells you again how many zeros you should have. All right, so let's do one last one, which is very similar. So if we go ahead and start this off on your own, you can pause it and then unpause to check your work. So -2 is the 0. And then we got 3, 2, 1, 0. So we're not missing any coefficients. Bring down that 2. 2 times -2 is going to give us -4. Add those together to get 4. 4 times -2 is -8. Add those together to get 9. 9 times -2 is -18. Add those together to get 0, which is what we want for the remainder. So this would be 2x squared plus 4x plus 9. And again, we're trying to solve this. So if I take the 2 and try to factor, 2 times 9 is 18. I don't have factors of 18 that add up to 4. So this is not factorable. Because it's quadratic, we can use the quadratic formula. So you have to remember the quadratic formula now. So just as a reminder for the quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. So in this case, our a is 1, b is 4, c is 9. So we're going to plug that into our quadratic formula. So x equals -4 plus or minus the square root of b squared, so 4 squared minus 4 times a times c, so 4 times 1 times 9 over 2 times a, which is 2 times 1. So you get x equals -4 plus or minus. Remember, you want to find the exact solution. So we're going to simplify what's underneath the radical to see what it gives us. So 4 squared would be 16 minus 4, and that's supposed to be 4 times, I just realized I did that. This is 2x squared, so this a should have been 2, not 1, sorry. Change that, so that would be 2 there, and a 2 here, so that means this should be 4. Sorry, I didn't realize I had put 1 instead of the 2 for the a. So then 4 squared minus 4 times 2 times 9 would give us -56, I believe. Yeah. So for this, then I want to simplify that. So I'm going to do some work off to the side over here. So if I have a negative underneath the radical, remember that becomes I root 56. So remember, to simplify your radicals, we're going to break down our factor tree. So 56 breaks down in a few different ways. So let's say you do 4 and 14, and then 4 breaks down into 2 times 2. 14 breaks down into 2 times 7, and then those don't break down anymore. Those are prime numbers. So we're looking for our groups of 2. So I see one group right here. The 2 and the 7 don't make a group, so those going to get stayed underneath the radical multiplied, and the 1, 2 goes on the outside. So this becomes 2i times the square root of 2 times 7, which is 14. So this equals -4 plus or minus 2i root 14 over 4. Remember, we're not going to use our calculators to find the decimal of the radical. We want the exact solution. So we can simplify this still. So we have -4 over 4 plus or minus 2i root 14 over 4. And so if we simplify this, we get -1 plus or minus I root 14 over 2 would be how you could write that. You could also keep it together and just divide up the 2, but I like to simplify it as far as I can, so we'll leave our answers like this. So that means then the zeros, we should have 3. The given one was the -2, so we have the zeros of x equals -2, and then remember, this gives us 2 answers. Our 2 answers are -1 plus I root 14 over 2 and -1 minus I root 14 over 2. So those are the zeros of our equation, which remember means there's the x-intercept solutions, the roots. All right, so last part. So we have our factor theorem and remainder theorem. The factor theorem states if f of c equals 0, then x minus c is a factor of the function. If x minus c is a factor, then f of c equals 0. And the remainder theorem states that if f of x is divided by x minus c, then the remainder is f of c. So it says use the factor theorem to determine whether the function has the following factors. So if they're going to be factors, then that means that when I plug that value into my equation, should get 0 out, because remember, if they're a factor, that means they're an x-intercept. And when you have an x-intercept, that means that your y value is 0. So if you find the 0 here first, so we get x equals 1. So if I do f of 1 and plug that into my equation, then if I get 0 for an answer, then that tells me it's going to be a factor. If not, then it would not be. So if I do plug this in, I get 0. So yes, x minus 1 is a factor of f of x. And that's because the remainder is 0, which means then, again, if the remainder is 0, that you have a y coordinate of 0. So this would be the point 1 comma 0 on the graph. Looking at the next one, if we do the 0, we get -2. So f of -2, if I plug that into my function, I would end up with -16 minus -2 squared is 4, minus 4 minus 3, which is obviously not going to give us 0. This would give us -27. So no, x plus 2 is not a factor because our remainder is -27, which means it's not going to be an x-intercept of your graph. Another thing you can you can do synthetic or long division if you want. It would just take longer to get to your answer. It's a lot easier just to plug it in using your remainder and factor theorem. So the next one says find the remainder if this is divided by each of these. So it's the same idea. So if I were to do find the 0 first, which is x equals 3. So if I do f of 3, whatever I plug that in, it gives me my y value, which is also the remainder if I were to do synthetic or long division. So this would give me 3 cubed minus 4 times 3 squared minus 5, which gives me -14. So the remainder if f of x is divided by x minus 3 is -14. So if we do this one over here, find the 0 first. So if I do f of -2 into the equation, this gives me -8 minus 16 minus 5, which gives me -29. So the remainder, if f of x is divided by x plus 2, will be or is -29. So again, if you wanted to do synthetic or long division, that would give you your remainder by the remainder theorem. And that is all for today's lesson.